This is a video for AQA Mechanics, Work, Energy and Power, section 2.4, where we're looking at power, force and velocity. Well, we've already met the idea that power is the rate at which work is done. Therefore, power is work done over time taken. But we can calculate the work done as being force multiplied by distance moved. And if we then think of that as being force multiplied by distance over time taken, then we get an alternative definition for power, which is force multiplied by velocity. So the power is equal to force multiplied by velocity, or we can express that as an equation, P equals F multiplied by V. Usually then, when we are dealing with this equation, we're considering something like a car or moving along a road and the power being developed by the car's engine. So F is going to be the engine's tractive or driving force, and we normally use something like Ft or D to describe that, and V is the velocity of the vehicle. Now this is going to be a constant or a maximum or instantaneous value. So it's this formula P equals FV that I want to use in a couple of examples now. The first example says we want to calculate the power developed by a car's engine which produces a driving force of 1000 newtons when travelling at a constant speed of 45 kilometers per hour. Firstly, we need to convert 45 kilometers per hour into meters per second. So we do that by the usual method. 45 kilometers is 45,000 meters and an hour is 3,600 seconds. And that gives us a value of 12.5 meters per second. And so using our formula P is equal to the tractive force Ft multiplied by V, we get that P is equal to the tractive force 1000 multiplied by 12.5, which is 12,500 watts or 12.5 kilowatts. Well, in the second question, we've got a car of mass 1.5 tons or 1500 kilograms, and its engine is working at full power of 20 kilowatts. We have a constant resistive force of 600 newtons. So we're asked to find the acceleration when it is moving at a speed of 10 meters per second. Well, the first thing to do is to use the formula P equals tractive force multiplied by velocity to work out the fact that the tractive force Ft must be equal to the power, which is 20,000 watts divided by the velocity 10, so that gives us 2,000 newtons. We can then use F equals ma, so that we get a total force 2,000 minus 600 for F is equal to 1,500 times A, and that gives A as being equal to 1,400 divided by 1,500, which to three significant figures is 0.933 meters per second squared, meters second to the minus 2. In the second part of the question, we're asked to find the maximum speed of the car. Now, when we have a maximum speed, therefore we have no acceleration. So A is equal to 0, and consequently this means that the net force is also equal to 0. So we can say therefore that the tractive force Ft must be equal to the frictional force, which is 600 newtons. The power being developed was the tractional force multiplied by V, and so therefore we get that V, the velocity, is equal to power divided by the tractive force, which is the power of 20 kilowatts, 20,000 watts, divided by a tractive force of 600, and therefore we get that being equal to 33.3 meters per second. Well, that's the end of this video on power, force and velocity, and indeed it's the end of the section of videos on work, energy and power.